So I wrote the general equation for the sine graph at the top. We really don't need it right now, but remember this is the equation where this is 4.5 page 304. I think I said 405 because I got 4.5 in my head, but it's 304. Okay, so I wrote the general equation of sine up there. The general equation of cosine and tangent would be the same thing. Actually, secant, cosecant, cotangent, all those parts are the same. We really don't need it for this question, but I just went ahead and wrote it up there just since that's the form we're talking about here. So we've got sine x. They want the x-intercepts. And you know, I'm going to go ahead and we're going to just look at the piece of the graph they showed us. I know this is negative 2 pi. Let me go ahead and this was negative 3/2 pi. This was right here is negative pi, and this right here is negative pi halves. I know kind of, you know, they're counting by pi halves here. So when they asked me for the x-intercepts for A, where are the x-intercepts on this graph?
They're at negative, I don't know that.
That's negative 2 pi if you count.
2 pi, and then, is that?
Negative pi. Yeah, count by pi halves. And remember, you can look at your book. I'm just trying to give you a general thing up here to refer to, but look at your book.
There's pi and 2 pi.
Okay, and 0, right? And then pi and 2 pi. Now, we could write this equation, we could write this list of answers a different way. And this is what you're going to see them do in the book. If I want to write all the answers, not just list what I see in this picture, do you notice that they are multiples of pi, right? So I could write that as pi n, and we're going to assume that when we do this in trig, we're always talking about n being an integer. N could be -1, 0, 1. It could be any negative number, 0, or any positive integer. It just needs to be a whole number, okay? So I could get all my answers if I list it this way. So this is kind of what we want to do unless they tell us that they just want the answers within a certain set of values.
So if it was pi n, would we just keep writing pi n, or would we multiply?
You would say pi times n, and then where n is an element of the integers,
okay,
which is z, okay? And so that would mean that pi times, you know, any integer you could think of would be an x-intercept that you could plug in there. So that's just a quick way of writing all the solutions to that, because there are an infinite number of solutions to that if we kind of think about the graph and where, you know, it goes on forever in both directions. They didn't tell us to limit it here, but, you know, if the book's just listing these answers, it's just limiting it. But extending it, this is how we could write it, and this is how I suspect the book would write it. I don't really want to take the time to flip back, but this is how we're going to need to write it in the future, is pi times n. So we're going to go ahead and get used to that notation now. And you see, it's just a quicker way of saying all that and then giving even more answers. So those are our x-intercepts. What's our y-intercept here for the B part? Well, how about, look, where does it cross the y-axis? 0, 0 at the origin. So the y-intercept is the origin. You can write origin or you can write 0, 0. Bless you.
Thank you.
So now we're just going to look for the part C at the piece that they've given us, because we couldn't really, there's not a good way to word this for all solutions. They want to know, first of all, the intervals that the graph is increasing and then the intervals that the graph is decreasing. So let's do increasing first. Where is it going up? I'll trace over in black right here, right? It's one place. It's going up.
Yeah, and then from 0 to half of pi.
So let's say from negative 2 pi. Let's write here's what we can do. We'll write it this way. You know, use a parentheses for your coordinate points, like a point on the graph, 3, 4. But you also can use it to say on an interval where you're starting and where you're ending. If I make the bracket blocky like this, okay, that means I'm including the value. At 0, it's not, right there on the x-axis, that's kind of a point where it's changing direction, so I'm not going to include that point. So I'm going to say from negative 2 pi to negative 3/2 pi. I can write it that way, and that means between those two numbers it's increasing. Here's all that, right?
Pi to 2.5 pi.
Let's see. From what now?
2 pi to 2.5 pi. Or you're not supposed to go more than 2.5 pi.
Over here? Are you talking about over here?
Yeah.
Yeah, it is here. It is here. Let's go like from left to right. We'll kind of right from, so that will be one I'll put in a minute, okay? There was one in between there from negative pi halves to pi halves, right? Kind of hard to write on this thing. And then the one you mentioned from, what is that, 3/2 pi to, because it starts going up down here at the bottom, doesn't it? So it would be from 3/2 pi up through, let's see, it goes past 2 pi on up to, that would be what you were saying, 5/2 pi, is that what you said?
Well, I said
2.5 pi.
2.5 is where I said it would stop.
So it'd be like 5/2 pi if we write it, because we're going to, most of the time, we don't, we're really not going to use those mixed numerals. We'll just write it like that, but it's the same thing as what you're saying. So for this little piece of the graph, that's where it's increasing. Now the decreasing part, let me stop. Oh, okay, that was, well, how about, okay, here's what I'm getting at. How about, you could, 0.5x. If we just use fractions, that'd be a half x, right? So this, if you look at this, do you remember, oh, duh, I wish I hadn't done that. That's not what I meant to do. This would be cosine, I meant to label it down here. This is bx minus c. Okay, so can you see that your b here would be 1/2? And that's b. That's not your period, but it helps you find your period. Do you remember how to find the period from yesterday?
No.
The period is equal to 2 pi divided by b. So 2 pi, if I want to find my period, that was one of the things they asked me here, 2 pi divided by 1/2. Boy, complex fractions all over the place in trig, right? Wouldn't that be 2 pi over 1? If you're thinking about how would I reduce that, you could put 2 pi over 1 times 2 over 1. Remember, when we divide, we multiply by the reciprocal of the denominator. So that would mean my period is 4 pi. So that half there seems like it would, if you think, well, let's talk about what's it doing to the period, how often this repeats. A small number,
It's going to make it go twice as long.
It's longer, right? So it's actually climbing, the graph is climbing slower, so it's really stretching that period out over a longer period of time. So when you see a fraction, it's meaning that it's climbing half as much. So that means it's going to be stretched out wider. So a fraction means that as your b there makes your graph stretched out wider. It kind of stretches it horizontally, doesn't it? So a number like 2 would kind of shrink it up horizontally. So that number out in front of that x is affecting our period there. All right, so what is my amplitude here? That's what one of the things they're asking me, 1/3. What does that mean? Instead of going up to 1 and -1, what is my graph, if I were to graph this, going to go up to?
1/3.
And down to? Okay, so do you see how you could sketch it just the same way that you normally would and then just plop the 1/3 and the -1/3 on there? And that way you don't really have to go to 1/3 of a unit to put that there and try to squish that little graph in. You can just make it as, the height you want it to work with it, and then just label that. So that's usually that's just a nice way to be able to try to graph these without driving yourself nuts. So that was this part. How am I going to find my period here? It's 2 pi over b, so what is b here? 4 pi. So that, anything in front of the x is your b. So 2 pi over 4 pi. The pi's cancel out, and I get, what, a half is my period? That's kind of weird. So every 0.5, I've completed a cycle of this thing. That's not even like, that's hard to think about in terms of like if you were to label in your graph with pi halves and pi and 3 halves pi and 2 pi, that's just really hard for us to fit into that scheme, isn't it? So those to me are the harder ones to graph when you've got something like that. If you look at your book, they didn't even try to graph that one. And they don't ask us to, thank goodness. All right, so that's good. Let me stop this.